Okay, so this practice quiz has got three basic types of problems on it. It has some molar mass calculations, some percent composition calculations, and some mole conversions. So let's talk a little bit about the first one. In the case of MgNO3, which is magnesium nitrate, there's one magnesium. This 2 distributes itself by multiplying times 1, so there's 2 nitrogens. And that 3 distributes itself by multiplying times 3, so there's 6 oxygens. So 1 magnesium times the mass of magnesium, which is 24.31 grams, gives you 24.31 grams of magnesium in this formula. 2 nitrogens times the mass of nitrogen, which is 14.01, gives me 28.02 grams of nitrogen. And then lastly, 6 oxygens times 16 gives me, I believe that's 96 grams of oxygen. And so when I add all of that together, so if I take the 24.31 plus the 28.02 plus the 96, I get something like, what is it, 124.02. Nope, that's not right at all because I put the wrong thing in. 24.31 plus 28.02 plus 96. That looks more like it. Should have been 148.33 grams per mole, and that's going to be of MgNO3 2. And there's one other way that we could probably write this as an answer and get full credit for it. 148.33 grams over 1 mole. MgNO3 2. So in this instance, to get full credit, we have to have the right unit, grams per mole, and we have to have the label MgNO3 2, in addition to the math part being right. So in the case of the second example, you had 6 carbons, 5 hydrogens, and 1 chlorine. So I took 6 carbons, so 6 times 6 carbons times 12.01 grams is 72.06 grams of carbon. 5 hydrogens times 1.01 grams is equal to 5.05 grams of hydrogen. And then 1 chlorine times 35.45 grams is 35.45 grams of chlorine. We're going to add that together. So 72.06 plus 5.05 plus 35.45 gives us something like 112.56, again, grams per mole of C6H5Cl, or you could write it as 112.56 grams over 1 mole of C6H5Cl. So those are the ways that you could do those two problems. Any questions here? The next problem on here is calculating the percent composition of elements in the compound. So there's 2 steps to these types of problems. One is to calculate the molar mass. So in this problem, there are 13 carbons, 18 hydrogens, and 2 oxygens. So 13 carbons times 12.01 grams. 13 times 12.01 is 156.13 grams of carbon. 18 hydrogens times 1.01 grams gives me 18.18 grams of hydrogen, and 2 oxygens times 16.00 grams gives me 32.00 grams of oxygen. So we're going to add all of that up. So the 156.13 plus 18.18 plus 32 gives me a molar mass of 206.31 grams per mole of C13H18O2. The second step in here is to calculate the percent of each element. I ran out of room. Try that again. Calculate the percent of each element. And so with that, we are going to use the percent of carbon is equal to 156.13 grams of carbon over the total, which is 206.31 grams of C13H18O2. And then again, that is going to be times 100. So 156.31 divided by 156.13 divided by 206.31, and then eventually multiplying it times 100, you're going to get a percent carbon to be 75.68%. For the hydrogen, we're going to take the 18.18 grams of hydrogen, put it over the 206.31 grams of C13H18O2 times 100. So the 18.18 divided by 206.31 times 100 gives me 8.81% hydrogen. And then lastly, oxygen is we're going to take the 32 grams of oxygen and put it over the 206.31 grams of C13H18O2 times 100. So 32 divided by 206.31 times 100 gets me a percent of oxygen equal to 15.51%. Any questions about this?
So would we have to show like the labels when we're dividing everything to the percentages or no?
I feel like it's a good idea to be in the practice of showing the labels, because it's just knowing, like, it looks to the onlooker as if it's just random numbers otherwise. Or at the very, very least, there should be some designation of what it is you're doing. Okay. The next section here, we had to go ahead and use dimensional analysis to convert from mass to moles to molecules and things like that. And some things I want to call your attention to on this practice quiz is that we did go through the process of actually calculating all of the molar masses for you, so you did not have to calculate them. Some people did this morning, went through the process and calculated them anyway on their own. And then we also, so just be aware that they're going to be given to you tomorrow. And then also we gave you the relationships between molecules and moles and formula units and moles. So here we go. Remember that when you're converting here, you're going to be talking about mass to moles to particles. So that's your kind of flow chart there, and we can go backwards and forwards here, like so. But you just might want to keep that in mind. So in the first problem, we are converting 2.36 times 10 to the 24 molecules of SiO2, and we are going to convert it to grams or mass of SiO2. So in this problem, we are going to go from molecules to moles to mass. And so I'm going to take my given information, which is the 2.36 times 10 to the 24th molecules of SiO2, and I'm going to put it over 1. And because it's going to go molecules to moles and moles to mass, I can see that I'm going to have a multiple step problem here. So in this problem, it's going to be two steps, molecules to moles and moles to mass. Now, in this instance, I see up above that I have a relationship of molecules of 1 mole is equal to 6.02 times 10 to the 23rd molecules. Why did that do that? Well, that's weird. So I've got my 6.02 times 10 to the 23rd molecules is equal to 1 mole. So that's my relationship that I'm going to use to begin with. So I'm going to try to cancel out molecules by putting 6.02 times 10 to the 23rd molecules of SiO2 on the bottom and 1 mole of SiO2 on the top. And then the other thing that I see here is that the molar mass has been calculated for me. So in reality, I know that in 1 mole of SiO2, the molar mass is 60.90 grams. So now I have the ability to go ahead and set this problem up. I do want to cancel my moles out, so I'm going to put 1 mole of SiO2 on the bottom, and I do want to put the 60.09 grams of SiO2 on the top. I'm going to calculate, so I'm going to take the 2.36 second x to the minus 1, 24 times 60.09. And then I'm going to take that answer and divide it by 6.02 second x to the minus 1, 23. And my calculator gives me a value of 235.568778. I do have to assess significant figures, so I'm going to draw my arrow and count 1, 2, 3. So I have 3 sig figs here. I'm going to draw my arrow and count 1, 2, 3. So I have 3 sig figs here. And my arrow and count 1, 2, 3, 4 sig figs here. My answer has to have 3 sig figs, so I'm going to draw my arrow and count 1, 2, 3. I see that this 5 can round that 5 up, so my final answer here is going to be 236 grams of SiO2, and I might put that in a box for safekeeping for later. Questions? In the next problem, we are converting 36.12 grams of C2H5O2N to moles of C2H5O2N. So I'm going to start by taking my, try to figure out what I got going on here. So I've got mass, and that's going to go to moles. So I'm going to take my given here, which is 36.12 grams of C2H5O2N. Put it over 1. And because I'm going just mass to moles, I only need 1 step here. And I'm really, really thankful that I don't have to calculate the molar mass on this one, in large part because that feels like a lot of work. So I do see that in 1 mole, there are 75.08 grams of C2H5O2N. So I'm going to set this problem up where I cancel out my unit of grams by taking the 75.08 grams of C2H5O2N and put the 1 mole of C2H5O2N on the top. I'm going to calculate this by taking 36.12 divided by 75.08. And the calculator gives me a value of 0.481086847. I do need to assess significant figures, so I'm going to draw my arrow and count 1, 2, 3, 4, 4 sig figs, and arrow and count 1, 2, 3, 4, 4 sig figs. So that means I'm going to need 4 sig figs in my answer, and I'm going to draw that arrow directly through that O, that 0, and go 1, 2, 3, 4. Draw a line and see that that 8 will absolutely round that 0 up. So my final answer is going to be 0.4811 moles of C2H5O2N. And I might put that in a circle so we can hang on to that later. Maybe an oval. I don't know. And then lastly, we have formula units. So 1.236 times 10 to the 24th formula units of Na3PO4, 2 moles of Na3PO4. So in this problem, I'm going from formula units to moles. So I'm going to take the 1.236 times 10 to the 24th formula units of Na3PO4, put it over 1, and it's a one step because I'm going formula units to moles. So I'm going to go back up here and look at my relationships, and I see that I get 6.02 times 10 to the 23rd formula units equal to 1 mole. So that's my relationship I'm going to use here. So I'm going to set this up so formula units cancel out. So 6.02 times 10 to the 23rd formula units of Na3PO4. And I'm going to put my 1 mole of Na3PO4 on the top. I'm going to plug this into my calculator. 1.236 second x to the minus 1, 24, divided by 6.02 second x to the minus 1, 23. And my calculator gives me a value here of 2.053156,146. I do need to assess significant figures, so I'm going to count 1, 2, 3, 4 sig figs here, and 1, 2, 3 sig figs here. So my answer needs to have 3 sig figs. So I draw an arrow and count 1, 2, 3. I usually draw a line, and I see that that 3 cannot round that 5 up. So the answer is going to be 2.05 moles of Na3PO4. I might put that in a cloud because it's lofty. Okay. So you do have a quiz in real life tomorrow. So hopefully you'll have a little bit of time to prepare for that. Otherwise, have a good evening.